You can analyze your data using association and model development, and statistics can be used to determine the relationship between parameters, such as correlation analysis, while we can also use statistics to develop models using regression analysis. So correlation and regression analysis is what it means by analysis through association and model development. Correlation is a statistical method to determine the relationship between two or more variables, or sometimes called univariate analysis. Simple correlation refers to the relationship between only two variables, x and y, a and b, or air pollution concentration PM10 and temperature. While multiple correlation, uh, in contrast to simple correlation, refers to the relationships between more than two variables. For example, between temperature, relative humidity, and PM10 concentration. We start off correlation or association analysis or model development analysis using a scatter diagram. And a scatter diagram is a graph of paired parameter x versus parameter y values to study the behavior of the two variables. A scatter diagram consists of the horizontal x-axis to represent the range of one variable, usually the independent variable, and the vertical y-axis to represent the range of the second variable or the dependent variable. For example, the x-axis is temperature while the y-axis is PM10 concentration. We can calculate the correlation coefficient in a correlation analysis by using the equation shown here. The correlation coefficient is used to measure the strength and direction of the linear relationship between two quantitative variables x and y. So it is a value, this correlation coefficient, that can be used to show how strong the relationship is between x and y or between temperature and PM10 concentration. Correlation coefficient is also called the Pearson product moment correlation coefficient. The symbol for the sample correlation, sample in opposed to population, where sample is a smaller subset of population, is denoted as small letter r, while for the population correlation coefficient is denoted as rho, Greek letter rho. Correlation coefficient is calculated using that equation as mentioned before, where we process the data per column and we produce products of the data between columns and minus between them and dividing and square root and so on to calculate the correlation coefficient. Now in this course you're not expected to calculate the correlation coefficient by hand because you've done this in previous courses or in previous institutions, and also we have access to softwares that we're able to calculate this correlation automatically and quickly. And in this course you'll be using on how to calculate these values using those statistical software. The range of the correlation coefficient is from -1 to +1. If the value of the correlation coefficient r is close to +1, this means a strong positive linear relationship between x and y or the two variables. If the value is close to -1, this means a strong linear relationship as well, but negative between the two variables. If the value of r is close to 0, either positive or negative side, in the positive or negative side, this indicates that there is no significant linear relationship between the two variables. Moving forward from correlation is regression or model development. In simple regression, there are only two variables. We have the independent variable or the explanatory variable or the predictive variable. The independent variable is on the x-axis while the dependent variable is on the y-axis. The dependent variable is also called the response variable. In simple linear regression, we model the dependence of the independent variable, the dependence of the dependent variable or the response variable on the independent variable. So it's a univariate or two variable analysis. But in multiple variable regression analysis, there are two or more independent variables on the x-axis, but only one dependent variable. The independent variables are used to predict the dependent variable in both simple and multiple regression. This is the regression model equation that can be developed after running the regression analysis. The regression equation describes the relationship between two variables, the relationship between, again, a dependent variable, y, and one independent or response variable. The equation is as follows. Y, which is the dependent variable, is equals to the constant beta naught plus beta 1 multiplied with the independent variable x plus an error value epsilon. It is also written there, beta naught is the y-intercept of the regression equation, or the constant, and beta 1 is the slope of the regression equation. In simple regression, the predicted, estimated, or fitted model equations can be written as follows, and this is somewhat similar with the previous equation, where again y hat is the dependent variable equals to the b0, b0, similar to the beta naught value in the previous slide or equation, plus b1, which is the slope constant, multiply with the independent variable x. The difference between this equation and the previous equation is that this equation is meant for the samples, while the previous equation is for the population. And we would assume that the b0 and b0 and b1 are estimations of the beta naught and beta 1 for the population equation, while y hat is the estimation for y. This is how we interpret the regression equation. That is for this slide, it is the b1 or beta 1 value. If the b1 value is positive, this means the fitted model is able to increase the response through the independent variable. Now, if it's a negative sign, then the independent variable decreases the response, or the dependent variable. How well the model fits the data can be assessed using the coefficient of determination, or R-square value, and this value is different than the correlation coefficient small r value. Now, the R-square value is the ratio of the explained variation to the total variation, and it ranges only from 0 to 1, in contrast to R correlation, simple correlation, where it ranges from -1 to +1. We can calculate R square by calculating the explained variation divided by the total variation. In other words, R square value is a factor or a percentage, where if it's closer to 1, the model is able to explain the variation of the data well, while if it's close to 0, it's not able to explain the variation of the data. Multiple regression is an equation that can be used to describe the relationship between, again, the dependent variable y, but with more than one independent variable, denoted here as x1, x2, until xk. It can be used to study the relationship between one dependent variable and several independent variables, and the general form of the estimated multiple regression equation is shown below, where y hat represents the predicted value, or the dependent variable, or the response variable, and the b0, b1 until bk are the regression coefficient, similar to the b1 in the simple regression equation. And the x1, x2, and x3 are the independent variable. This method is able to account for all of the independent variables' effects on the dependent variables. But keep in mind that the addition of more independent variables does not necessarily increase the correlation of the model, the coefficient of determination value of the model. Sometimes it could actually decreases it. So when you develop such models, you need to balance the amount of independent variables included into the model.